Okay, hi. In this experiment, which is entitled the enthalpy of decomposition of hydrogen peroxide, we're going to take some hydrogen peroxide, add an iron catalyst, place it in a calorimeter, which is essentially an insulated container, and see how much heat is released. From that, we should be able to find the enthalpy of decomposition of hydrogen peroxide in kilojoules per mole. So the basic idea is that hydrogen peroxide releases heat, so it's an exothermic reaction when it decomposes, and we can accelerate that process using an iron catalyst. The balanced chemical equation is shown here. Hydrogen peroxide is an aqueous solution in the presence of an iron catalyst, so notice it plays no role in the balanced chemical equation. Will turn into water and oxygen and will release some heat. We'll measure how much heat this reaction releases in kilojoules per mole. Here's a sample problem which should pretty much help explain any calculations or understanding related to this experiment. Imagine you have 8.2 grams of a 3% by mass aqueous hydrogen peroxide solution, and you have 1.8 grams of iron nitrate, that's iron 3 nitrate catalyst solution. We combine them in a calorimeter and we find that it gets 10 degrees hotter. What's the enthalpy of decomposition of hydrogen peroxide in kilojoules per mole for this experiment? Well, we need kilojoules per mole of heat released. To get the kilojoules, we can use the specific heat equation, which is Q equals mc delta T, where Q is the heat released in joules per mole. We'll have to turn that into kilojoules, or just kilojoules. There's not moles yet. The mass of the solution is 8.2 grams plus 1.8 grams equals 10 grams. The specific heat of the solution, we're going to assume it's largely water and simply use the specific heat of water, which is 4.184 joules per gram degree Celsius. The temperature change was 10 degrees Celsius. This gives us 408 joules, or 0.418 kilojoules. We now need the moles of the hydrogen peroxide, and it was 8.2 grams, but not of hydrogen peroxide, rather of a 3% solution. So we multiply by that times 0.03. That's how much actual hydrogen peroxide is in there. And we note that 34 grams is a mole, giving us 7.23 millimoles of hydrogen peroxide, or 0.00723 moles of hydrogen peroxide. Finally, kilojoules per mole, just divide them and you find that it releases, that's why we have a negative number there, 57.8 kilojoules per mole of hydrogen peroxide. I won't list the procedure as usual, but I'll point out a couple of tips. Get LoggerPro up and running. Mass the peroxide into your calorimeter. Mass your catalyst solution so you have your total mass, just like they did up here. Start the program and then mix them in that order. End it after 10 minutes and you should get a curve roughly like this. Your delta T should be readily apparent. Note that the final temperature needs to be extrapolated from that line. So use the equation of a line, y equals mx plus b, to get that number rather than a number down there. That's step 12, and follow it carefully and you should be fine. Here's the 6 calculations we'd like. The final temperature using y equals mx plus b to get that. The change in temperature, T final minus T initial. The heat released in kilojoules, use the sample calculation as an aid. The moles of hydrogen peroxide, use the sample calculation to aid you. The enthalpy of decomposition, hydrogen peroxide in kilojoules per mole, just take the kilojoules, divide it by the moles. And compare it to a theoretical value, where the theoretical value should be the heat of formation of water, right there, minus half the heat of formation for oxygen, right there, and hopefully there's some kind of a correlation between the experimental and the theoretical values. A few questions to consider while you are doing this reaction is, what's the role of the iron 3 nitrate? Why isn't it a reactant? What's the unknown this time, or is there an unknown? Why is the final value given a negative? And how do we determine the initial value? If you listen to the screencast, I believe that basically all those answers were provided for you. Why do we calculate the final temperature rather than just measure it? And this is the enthalpy of the decomposition of hydrogen peroxide.